In the previous video, we had learned about the line spectrum of hydrogen and all about it. In this video, we are going to be talking about the limitations of Bohr's model of the atom. Bohr's model actually helped explain various concepts that Rutherford's couldn't, but at the same time, it could not explain a certain concepts. So here are the limitations. So the first one, inability to explain the line spectra of multi-electron atoms. As we spoke about this, we spoke about when we spoke about the Bohr's atomic model for the hydrogen atom, I specifically told that this particular uh, those equations which we had studied for energy and the radius were applicable to atoms which only have a single electron. But as the number of electrons increased, the line spectrum started getting more complicated, and this was not explained by Bohr's atomic theory. Also, when there was a lot of when the quality of the spectra, which was made better, it it was observed that hydrogen had the lines. They actually, I mean, if you remember, we studied Balmer series, Passion series. All of those lines started to split into closely spaced lines, and this concept could not be explained by Bohr. Bohr's atomic theory. So the first point consists of two things. First, it was not able to explain the line spectra of when you have multiple electrons. Secondly, when we noticed that hydrogen atom was noticed with a better spectroscope, then it was noticed that those lines actually split to give two lines. And this particular thing or concept was not explained by Bohr's theory. The second is inability to explain splitting of lines in magnetic field and the electric field. So what happens is when the source which emits the radiation and it's placed in an electric or a magnetic field, each line is split into a number of lines. Okay, so one instead of having just one line, you have a number of lines. So splitting in the presence of magnetic field is called as Zeeman effect, and splitting in the presence of electric field is called as Stark effect. So the concepts of Zeeman and Stark effect was not explained by Bohr's model. The next, it was inability to explain the shape of molecules. It was unable to explain the shape of molecules because there was still no clarity as to how atoms bonded to form molecules and why the particular shape is linear, why a molecule is linear, why is it bent. All of such things were not explained by Bohr's concept. The last one was inability to explain de Broglie concept of dual character of matter and Heisenberg's uncertainty principle. Now, these two are so this actually posed as a very rather major issue or concern with Bohr's theory. It was not able to explain these two concepts. If you remember, apart from the stability and the location of electrons, Rutherford's theory was not able to explain the dual nature of electromagnetic radiation and atomic spectrum. Similarly, Bohr's theory was not able to explain de Broglie's concept of dual character of matter and Heisenberg's uncertainty principle. So, due to all of these limitations of Bohr's theory, we had to, or scientists had to devise a theory which could explain all of this. So that's about it. In this video, we learned about the drawbacks or the limitations of Bohr's atomic theory. In the next video, we will be doing a few index questions to do with this concept. And then we will start learning about how the most recent or whatever we learn right now, that atomic model, how did it come about? So do check out the next video for the index questions.